When we talk about the origins of computers and artificial intelligence, we usually think of the 20th century, Silicon Valley, Turing, NASA. But more than 300 years ago, there was a German philosopher who already dreamed of something extraordinary, that the human mind could be assisted by symbols, that arguments could be solved like equations, that reality itself could be understood through logic, clarity, and calculation. His name was Gottfried Wilhelm Leibniz, and this is the story of a man who tried to calculate the universe. Before we dive into his life and his ideas, hi, I'm Federico, and this is the Mind of the Masters. If you enjoy deep thinkers and world-changing ideas, make sure you like the video and subscribe. I also want to hear from you. Tell me in the comments, which thinker, which writer, which revolutionary mind should I explore next? There's a new episode every day. So now, let's begin. Chapter 2. Gottfried Wilhelm Leibniz was born in Leipzig in 1646. From a very young age, he was surrounded by books. His father was a professor, and the university library became his playground. As a teenager, he was already reading advanced philosophy and theology, and he rapidly became what we would today call a true polymath. He worked as a diplomat, historian, theologian, mathematician, logician, inventor, and librarian. He traveled across Europe, met scientists, kings, theologians, scholars, always searching for patterns, systems, and clarity. In mathematics, he created the symbols of calculus that we still use today. The symbols dx and come from Leibniz. He believed that good notation makes thinking easier, but his ambition went beyond numbers. Leibniz wanted to understand the architecture of reality itself, not only how things happen, but why they happen the way they do. To him, the universe was not chaos, it was design, and his life's mission was to discover the underlying logic of that design. Chapter 3. For Leibniz, reality is not made of tiny pieces of matter, like atoms. Instead, the universe is made of monads. A monad is like a tiny, living point of awareness. It has no size, no physical extension, but it perceives the world from its own perspective. Every monad is a little universe in itself. To imagine it, think of a digital screen. Each pixel shows part of the image, but it doesn't touch the others. Yet together, they form the complete picture. Or imagine a mirror. Each monad reflects the entire universe, but in its own unique way. Some mirrors are clear and detailed, like humans, capable of reason. Others are blurry, reflecting reality only faintly, like animals, plants, or even stones. Every monad is active. It has its own inner life. It changes and develops from within, according to its own perception. In Leibniz's vision, the universe is made of countless monads, each one independent, yet together creating the harmony we experience as reality. And this leads us to one of his most famous ideas, the pre-established harmony. Chapter 4. Leibniz believed that monads do not physically interact with each other. They never push or pull one another. So, how does the universe stay coherent? The answer: a pre-established harmony set by God from the very beginning. Think of it like two perfectly synchronized clocks. They move together, show the same time, yet they never touch each other. They were simply designed to run in harmony. Or imagine a massive orchestra. Each musician plays independently without looking at the others, but the sheet music ensures that all notes combine to create a perfect symphony. In our daily life, it's similar to software functions. Each function runs separately, but the program as a whole produces a seamless result. In Leibniz's universe, every monad follows its own internal logic, yet all monads align perfectly with one another. This idea allows us to see the universe as orderly and rational, even if we cannot observe the connections directly. Next, we will explore another key principle, that shows just how rational Leibniz believed the universe to be. Chapter 5. Another cornerstone of Leibniz's thought is the principle of sufficient reason. It states that nothing happens without a reason why it is exactly so and not otherwise. Every detail, every event has an explanation, even if we cannot see it at first. Imagine a chessboard. Every piece is moved according to a reason, even if you do not immediately understand the player's strategy. Or think about a recipe. The ingredients are combined in a specific way for a reason. The result is not random. Each step has a purpose. For Leibniz, the universe itself is like a grand, infinitely complex recipe. Every particle, every event, every monad acts according to a reason, part of a larger, coherent plan. This principle is what allows him to claim that the universe is intelligible, not chaotic. If we search carefully, we can uncover the reasoning behind everything we observe. And this idea leads naturally to one of his most famous statements, that we live in the best of all possible worlds. Chapter 6. Leibniz is famously quoted as saying, "This is the best of all possible worlds," but he didn't mean that everything is perfect for us, or that life is always easy. What he meant is more subtle. Among all the possible worlds God could have created, he chose the one that is most coherent, rational, and harmonious. The world we live in maximizes order and logical consistency. Think of it like a puzzle. There are countless ways to arrange the pieces. Some arrangements might look nice, some might break the picture. God, in Leibniz's vision, chose the arrangement that forms the clearest, most beautiful picture possible. Or imagine a programmer designing a software system. There are many ways to write the code. Some ways crash, some are messy, some are inefficient. The best system is the one that works flawlessly, logically, and sustainably. For Leibniz, the universe is like that, not perfect for human comfort, but perfect in terms of overall coherence. Subsection: the problem of evil and God's goodness. One question naturally arises: if God is perfect and good, why does evil exist in the world? Leibniz's answer is subtle. He argues that God's goodness is universal and rational, not measured only by human comfort. The universe God created is the best possible world, maximally harmonious, coherent, and rational. Some suffering and evil are inevitable consequences of this grand design. Think of it like a symphony. A few dissonant notes may sound harsh on their own, but they are necessary for the harmony of the entire piece. Or imagine a programmer designing a complex system. Certain constraints or problems are unavoidable, but they are necessary for the program to function perfectly overall. Evil and suffering, then, do not contradict God's goodness. They exist as part of a larger rational order, necessary for freedom, natural laws, and the coherence of the universe. In Leibniz's vision, God is not indifferent. He is perfectly good and creates the world in such a way that even what seems like evil serves the perfection of the whole. Chapter 7. Leibniz was not only a philosopher and mathematician, he was also a visionary thinker who anticipated modern computing. He dreamed of a universal language of symbols called the characteristica universalis. In this language, every idea, argument, or problem could be expressed clearly, unambiguously, and even solved mechanically. Imagine a world where philosophical debates could be solved like equations. Two people could argue, and instead of endless discussion, they would simply calculate the answer. Think of it like modern programming. A function takes inputs, follows precise rules, and produces a predictable output. Leibniz imagined reasoning itself working the same way, logic and calculation combined to clarify truth. He also worked on mechanical calculators capable of performing addition, subtraction, multiplication, and division. He wanted tools that could extend human reasoning, making it faster, more precise, and reliable. In many ways, Leibniz laid the conceptual foundation for computer programming, formal logic, artificial intelligence, symbolic reasoning. He saw the human mind as something that could be assisted by symbols, rules, and calculation. A vision strikingly similar to what we are building with computers and AI today. Next, we will see why all of Leibniz's ideas, from monads to logic, still matter in the modern world. Chapter 8. Leibniz lived over 3 centuries ago, yet his ideas continue to resonate in our modern world. He believed that reality is fundamentally logical and mathematical. He believed that the mind could be assisted by symbols and rules to uncover truth. He imagined a world where reasoning itself could be calculated, a world where logic and formal systems guide understanding. Today, when we write code, build algorithms, or design artificial intelligence, we are walking on the path he helped to pave. Software functions, neural networks, and symbolic AI all echo his vision. Systems that process information according to rules, producing coherent results without chaos. Even in philosophy, his insights remain relevant. Monads remind us to consider multiple perspectives, each point of view contributing to a larger whole. The principle of sufficient reason inspires us to search for explanations behind every phenomenon, no matter how complex. And the idea of a best possible world encourages us to seek logical coherence and design in the systems we create. Leibniz didn't just ask, what is the universe? He asked, how can the universe be represented, understood, and calculated? In a sense, we are still answering his question today, with computers, AI, mathematics, and logic. Leibniz may have lived in the 17th century, but his mind was already thinking like ours, imagining a world where reason and calculation illuminate reality. He tried to calculate the universe, and perhaps, in a certain way, we are still continuing that work. Closing. Gottfried Wilhelm Leibniz lived in the 17th century, but his ideas continue to echo in the 21st century. From the logic behind modern programming languages to our understanding of information, perception, and reality, Leibniz remains a thinker of astonishing modernity. He tried to calculate the universe, and maybe, in a certain way, we are still trying to finish what he started.